Hi, today we are going to focus on Game&Watch, Legend of Zelda in this case, and I'll show you how to get from this to this. We'll be flashing custom firmware to the device and running several emulators. So to do that, what you'll need is the device itself, you'll need Raspberry Pi, you'll need a screwdriver, and you'll need some wires. You'll also need soldering iron that's not shown here on this screen. As for the screwdriver, you will need the tri-wing bit because the screws are exactly like you see here. So you start by removing the 4 screws as shown here. And once that's done, you just take the back off. Just be careful when taking the back off. The power button tends to fall off, so don't lose it. Just carefully take the back off. And now you'll need to disconnect the battery, and we'll be soldering wires to the debug connector shown there. There's also a flash chip next to the battery on the right hand side of the battery connector, which we'll be also removing and replacing with 32 megabyte flash. We'll do that under the microscope. Before we start soldering, I'll just show you the plug, the other end of the wires that I'll be using. So 3 wires and the connector that will be plugging into Raspberry Pi. This is the debug connector, and I'll show you the. I'll put a diagram here. But the important pins are pin number 2, which is SWDIO, pin number 3, which is ground. So pin number 2 is blue, pin number 3 ground is green, and then pin number 5, which is SWCLK, which will be yellow in our case. So you just need to solder these wires to those pads or holes or connector. Obviously, the tip that I'm using here is just too small, not enough heat transfer. So I'm switching to a larger tip, which, as you can see, works perfectly fine for this application. Just make sure that these wires are not too long, or the exposed wires are not too long, and they are not touching on the other side of the board. So maybe preferably after you solder it, just test with multimeter or something to make sure that especially these 2 blue and green wires are not touching each other. So now the soldering part is done, or debug part is done, just making sure that it's soldered correctly and not touching. I'm just cleaning the port, again making sure those solder blobs are not touching each other, and that's it, job done. So here's the Game&Watch. It's connected to the power. It's not powered on yet. Battery disconnected. As you remember, the blue wire goes to SWDIO, the green is ground, and yellow is SWCLK. So this is then connected to the Raspberry Pi. The blue wire, SWDIO, goes to pin 18, or easier, it's number 9 on the outside. So 1, 2, 3, 4, 5, 6, 7, 8, 9. This is pin 18 because you count it like this. So you do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, and then 18 on the outside. Then next one is yellow ground, and the third one, which is 9, 10, 11th pin on the outside, is yellow, which is SWCLK. So with this setup, you can power on your Raspberry Pi, and we can now power on the Game&Watch. So let's just do that. I'll flip it over so that you can see the screen. So I will power it on, and I'm not sure if you can see this, but hopefully you can. So yeah, so Raspberry Pi powered on, Game&Watch powered on the clock screen, and I'll overlay my terminal. So here I'm logged into my Raspberry Pi. So what we need to do, we need to change to OPT directory. So right now we are in HomePi OPT, and then Game&Watch backup. You have a few scripts here, and you just go 1, 2, 3, 4, 5 essentially. So let's start with the sanity check. By the way, one thing you probably need to do is to add this line here for it to work. So I'll add it in the comments. So originally this line was here, and this path was obviously different to the, I think, older version of OpenOCD. So once you add that, or just export, or just paste that command in the command line, easier, place it in your bash rc file, and it will always be there. So with that, again, we are in HomePi OPT Game&Watch backup, and let's do sanity check. So what do? We run this script, we provide the interface, which is Raspberry Pi in our case, and the device type that we are using is Zelda. And this should come back with the looks good message. So now we are ready to do a backup. So let's just clear the screen, and let's run the second script. And again, the interface is Raspberry Pi, and the device type is Zelda. And again, make sure Game&Watch is turned on and in the time screen, which it is, as you can see. So let's press enter, and wait. Now this will take several minutes. Might be faster on Raspberry Pi 4, maybe. I'm using 3B Plus, I think. I can't remember what the model is. But anyway, it will take time. So I fast forward here, and we'll come back when it's done. So now the script has finished, and the backups should be in backups directory. And there you go. So now let's do the second step, or third, which is backup internal flash. So let's run the script, and again, the interface is Raspberry Pi, and the device is Zelda. This step will backup internal flash, and the device will be non-functional from now on, but don't worry about that. We'll unlock the device in next step, and then restore the flash in next step. The whole point of these steps is essentially to unlock the device. So let's continue with that. Okay, so now the process has completed. Let's just follow what's on the screen. So we'll disconnect the power from Game&Watch. connect it back again, and we will press the power button. And we've got a blue screen as on the instructions. So it's blue. Let's press return. And that was pretty quick. This step is completed. So let's clear the screen again. And let's do the fourth step, which is actual unlock of the device. So again, Raspberry Pi, Zelda, if I can type it correctly, and hit enter. And again, fair warning, anything can go wrong, but we have a backup, so hopefully we'll be fine. Device has been unlocked, and let's just do what it says on the screen. So power cycle again. So let's disconnect, connect it back. Let's clear the screen and run the fifth and final script, which is actually restoring the device to its original state. With one exception, the device will now be unlocked and we can run any other software. So again, Raspberry Pi, Zelda, and we need to wait. Okay, so the last step is done. Let's just power cycle the device. I will disconnect it from the Raspberry Pi and put the power back on. It won't power on because the battery is still disconnected, and we'll keep it like that for the moment. So let's connect it back, power it back again, and it should start as usual. So for now, there's really not much difference. The only difference is that this device is now unlocked and we can flash any software we want, including RetroGo, which we'll do in the next step. But first, let's upgrade the storage, the flash. So flash on this device on Zelda is, I think, 4 megabytes. On original Mario Game&Watch, it was, I mean, original. The Mario Game&Watch was 1 megabyte. This one is 4, I think, which would allow to put a few games, maybe 3, 4. I don't know, just a few games, really, not many games. So you can upgrade this device fairly easily. You can install 16 megabyte flash, which is fairly easy, or you can install 32 or 64 megabyte flash, which is a little bit more complex because it's in a different package. So, but it's doable. So let's do that now. Let's upgrade the flash on our Game&Watch. I have 32 megabyte chips, so I'll upgrade this one with 32 megabyte, and then we'll flash RetroGo. But to do that, we'll need to switch to the microscope again. So back under the microscope, this is the 4 megabyte chip that we'll be replacing. we'll be replacing it with 32 megabyte chip, which is in different package. So it's as you can see, it will be a little bit tricky to solder, but it's doable, and yeah, we'll do that right now. So we'll start with applying some flux. Flux is very important here. We'll apply flux, and then we'll use some sort of low melt solder. I think the one I'm using is Chip Quick. We'll apply low melt solder to the pins and then remove the chip. Now with the low melt solder, you need to be careful. As you can see, it melts very easily and it can make a mess everywhere, which I did here. And as you can see, it was very close to the capacitor, and that would be a disaster. But you just apply the low melt solder, and the chip just comes off very easily. Cleaning after all that is very important. You don't want low melt solder mixed with your regular solder. So all these remains of low melt solder need to be cleaned very carefully. All the pads have to be cleaned. Make sure there's nothing left on the board, and as I said, clean it very, very carefully. You don't need any low melt solder. So now a little bit of cleaning, and we'll be ready to apply and to prepare the pads for new chip. So the pads are a little bit small for the new chip to be soldered correctly. I mean, it can be done, but it's a lot easier if you just remove a little bit of solder mask. So that's what I'm doing now. I'm just removing a little bit of solder mask from those pads, and you can scrape it off with a scalpel or anything really. I'm using this micro Dremel or something. So I just removed the kind of top layer of the UV mask, cleaned it a little bit, and then I'll apply some solder, some minor corrections so that there's a little bit more of copper visible. And then again, these pads will be tinned with solder, which I'll be doing in a minute. Obviously, flux is your friend. Apply flux, as much flux as you can. Flux will never hurt. It helps with solder flow a lot, and so yeah, use flux, as much flux as needed. So once these pins are tinned, you just or covered with solder, just remove the solder, and the pins will now be ready for the chip. Yeah, so the pins are clean now. We'll just clean them off with IPA. Yeah, a bit more cleaning. And I'm applying a thin layer of flux just to keep the chip in place. Flux is sticky, so the chip it keeps the chip in place. Just checking the alignment. As you can see, the pins are aligned perfectly fine. Now I'll press down on the chip to make sure it lays flat on the board, and then again double checking the alignment, and everything seems to be in order, so aligned perfectly fine. So what's left essentially to keep the chip in place. So push it down and make sure it doesn't move, or it doesn't move too much, and just apply apply solder to the pins and to the pads. So just push against the pad and against the chip, and the solder will flow and make connection. The pins will make connections with the pads. So now that's done. So what's left is cleaning. Just making sure that the paths made connection with the board, and yep, and it's aligned perfectly, and there's solder there, and there's connection there, as you can see. So everything seems to be in order. And I'm just doing it again here, just to make sure that everything is perfectly fine. So a little bit more flux, a little bit more solder, and just to make it perfect, so that there's no doubt it's there is a connection between those pins and pads. Final touches, cleaning again, and more cleaning. And the job is done. So we are back with the new flash chip installed right here, as you can see. So let's go ahead and flash the device. We have a few options. We can flash RetroGo, classic RetroGo, without cover art or anything like that. We can dual boot, so we can flash original software, Game&Watch, original, I mean that came with the device, and we can also boot RetroGo. So I think this is the best option. But today I will cover just the regular RetroGo, classic RetroGo, and I'll do another video on dual boot, and also some interesting mode where I won't be using this this debug header. Well, I will be using it, but I won't. I will connect the two lines to the USB-C data lines, and by doing that, I won't have to open the device. I will just use USB-C to flash the device if I need to. So yeah, going back to what I'll do now is I'll flash the classic RetroGo to this device. So we are still in Game&Watch backup, which directory which we used to create backup, and make sure that you have backups directory. So all these files stored somewhere. So copy them, SCP them to a server or a flash drive or whatever. Make sure that you have copies of this. So now let's change directory to Game&Watch RetroGo. So in this this RetroGo directory, one important thing is that you have a ROMs directory. So I'll change to that, and you can put your ROMs that you want to flash to the drive. So I only put a few NES games, Sega Master Systems, and I think Game Boy. These ROMs, I own these games, so yeah, you have to source them somehow. So if I do say NES, you see that I have 1942, 1943, and Bomberman. So all this will be flashed to our Game&Watch. So let's clear the screen. Building flash and flashing is fairly simple. So what you do, you make sure that that your build is clean. What it means, every time you build the flash, the compiler and linker and all that, all these images, the files, intermediate files will be left in place. So if you build it next time, it will be they will be reused. The problem with that is that if you're flashing Zelda and then you're flashing Mario, these files might be different. So it's safer to do make clean every time you flash a new device. So first thing you need to do is make sure that the whole image fits in your flash. So in this case, I'm doing make size, target Zelda obviously, and the X-Flash size is 32 meg. So what this will do, it will build the files and make sure that it will fit in 32 meg flash. So let's do that. And this will take significant amount of time. So I'll come back when it's done. So now that's done. In the meantime, I flip the device so that you can see. By the way, I didn't mention that when you change the flash chip, obviously the device won't start, so don't panic. The flash is empty, so nothing is going to happen. I also connected the USB-C because the battery is still disconnected. All the leads are still in place, connected to the back port. So now, once this is done, what you need to do is you flash the image to your device. So again, the command make flash target Zelda flash size 32. So let's do that and see what happens. Okay, so that failed, and it failed probably because I need to press the power button while, not sure how to do this, maybe like that, while I'm running the command. So I'll press the power button again. Sorry, I'll do it again. So again, this will take some time. So it's all done, as you can see. I'll just remove the power. I'll disconnect Raspberry Pi and let's power it back again. See if it works. And let me remove this overlay. So there you go. Let's try and run some NES games, maybe Bomberman. Let's see if it works. And it sure does. There you go. That's your Game&Watch Zelda flash with custom firmware with several ROMs.